I'm not sure if I'm going to have to ask any questions. These guys love to have a great debate. So I may even open up a little sooner for everybody here to have a chance to chat with them, because we've got some heavy hitters here doing some great work in government. So I'd encourage you to think about some questions for them at the end. But to start, I already introduced myself at the beginning of this meetup. I'd like for you all to introduce yourselves and kind of what you're doing in data analytics in government.
So my name is Melvin Greer. I'm the Chief Data Scientist for the Americas at Intel Corporation, the very first one we've ever hired. Intel is primarily focused on moving away from data as an exhaust portion of the work that we do, that is, moving data as fast with as little power through our great silicon architectures as possible, and creating data as a function of fuel to develop insights into the content, context, and the rationale for using data in order to gain better understanding of what's going on in a business or in an agency. I'm responsible for all the domain spaces in the Americas, which includes oil and gas, financial services, retail, and of course public sector. I live here in Washington, and so anybody who can figure out why the chief data scientist for Intel lives in Washington? Anybody know? Anybody want to guess that? Yeah, so it's because the largest data sets in the world are here. The people who make the rules around data are here. And the people who are going to influence policy, ethical, legal, and societal implications associated with data, they're here. So if I was in Santa Clara, where our headquarters is, it'd be very difficult for us to influence the way things are going with data and data analytics in government. Now, I will tell you that we spend much of our time focused on great partners. And so full disclosure, Microsoft is a fantastic Intel partner, as well as Databricks. And I've been offered an opportunity to spend some Intel money on Jason's company. In the last 18 months, Intel has spent more than $1 billion acquiring between 27 and 28 new artificial intelligence companies, mostly focused on software. So all of the family of silicon architectures that you can imagine, plus software, creates in Intel an ability to develop an end-to-end solution without having to miss a beat or understand the direct implications to how data works in government. Now, I do have to tell you, I am also an employee of the Federal Bureau of Investigation. I just got hired at the FBI as a senior advisor and fellow, responsible for the Department of Justice and FBI's artificial intelligence, data science, and cloud computing strategy. And so the reason I mention that is because there's one thing that you should keep in mind about the federal government, and that is they are looking for the best talent that can help them learn how to turn the vast amount of data that they have into insights for immigration and healthcare and transportation and all the missions of the government. And so this body, as well as Karina and the rest of us, are keenly focused in on helping the government to do that. So I would encourage you to, if you haven't started in earnest, do that, because we absolutely need your talents. Thank you.
Oh, thanks, Mel.
Yeah.
Jason?
Hard to follow. That last thing you said, that last thing you said is incredibly important. With great power comes great responsibility, right? And that applies not just to the federal government, but also to private industry, who are being more and more trusted with data that we find personal and important and private. So it's a massive challenge. And Avrio Software specializes in data science. We provide data science support to the U.S. intelligence community, and we're also working to commercialize a software platform that we developed called SIFT that specializes in helping organizations migrate their unstructured data to the cloud. which turns out to be a pretty difficult problem for a lot of reasons. The challenges of managing data in all of its different and many various types are certainly tremendous. How many baseball fans in the audience? Anybody? Always a risk at a techie show. If you are not a massive sports fan, but you like technology, do yourself a favor and watch Moneyball if you haven't already seen it. Fantastic story about Billy Beane and the 2002 Oakland A's, where they effectively started using baseball big data known as sabermetrics to try to really fine-tune their recruiting and also actual player placement on the field and at bat and all the rest, and swept the league just without any obvious reason for being able to do so. It's just a fantastic story of how the data is out there, and if you can be clever about it and set up a good system for consuming it and using it. And P.S., this was long before Azure and AWS were really, the powerhouse environments that exist today. It was before Spark and Databricks, and certainly before Avrio and Sift. So it's the data's there. There's a tremendous responsibility to manage it carefully, and if you can be clever about it, there's some great stuff you can do with it.
Cool, and I'll introduce myself again. I'm Howard Levenson. I'm the General Manager for Databricks Federal. I've been with Databricks for 4 years, but I've spent my whole career working with the federal government, largely on, in the old days we used to call it high-performance computing. Today it's really about data, and it's called big data, but I've worked for Cray and Silicon Graphics and IBM in their high-performance computing areas. The reason I went to Databricks, I had a great job, and Databricks barely existed at the time that I joined the company. And I just felt like I wanted to change the world in some little way. And the thing that I really like about, the big data space is we have the potential to basically eliminate fraud in the IRS and, healthcare system. We have the ability to potentially, cure cancer with the work that can be done at NIH and National Cancer Institute. We have the opportunity to really, eliminate or reduce the amount of terrorism that takes place through the work that we do in the intelligence community. And I just find those types of things really inspiring. And the power of big data is fascinating. So every day I get to work with different customers that have unique problems that can be solved through big data, and that's why I'm here.
Well, definitely, I think in most conversations, data is the new oil. Really, it's the center of all, organizations in the future, I think, for most organizations. But with that, where do we start? What are the biggest, opportunity spaces or challenges for the federal government as they look at data? I think, we definitely produce one of the most vast amount of data in, here in government. To Mel's point, where do you start? What's the biggest opportunity space or the challenges?
Well, we're finding opportunities all over. There are no agencies in government that are not investigating the use of data science and artificial intelligence. Every single one of them is, and so there are some major areas where things are happening. Worth note, though, I think Howard's point around health and life science is really, really important. It's a $50 billion industry in the United States, and improving patient care through immunotherapy, synthetic biology, all of these require a focus on data science and artificial intelligence. I think certainly cyber analytics and moving from cyber defense to cyber intelligence. This move requires a focus on analytics so that we can become more predictive, well beyond things like the cyber kill chain, and more focused on being able to understand the rationale that a threat might have, classify the vulnerability, and be able to take an automated response. So these are all very, very important. But I think probably the most important thing that I want to reemphasize in the federal government is, in order to achieve any of these things, it's really going to require a massive reskilling and retraining effort. My boss, the CIO and CDO of the FBI, published a report today that said that the Department of Justice data strategy has as a key tenet inside it the development of a reskilling program inside government. It's absolutely critical that we get more people with the absolute necessary skills. And I don't mean skills like programming R, Python, and TensorFlow. I mean like asking questions like, can we do this or should we do this? So I think that's where we're really looking for some really differentiation. And I teach the master's program at 2 universities for AI, and many of my students, they understand how to code. They certainly understand how to develop data lakes and how to create massive ingest of data. But if you ask them, should we do this? That is a question that people are not prepared to answer, that we absolutely, in government, need to have people prepared to answer.
Yeah, and building off of that, right? So I'm a cybersecurity guy initially by training, so I tend to see the world in terms of confidentiality, integrity, and availability. And asking the questions ahead of time, to what levels of confidentiality are important to a given set of data or data sets in combination, which can sometimes change a data set's classification or sensitivity. How important is data integrity in different use cases? It can be incredibly important, it can be not so important. One example I love to use is, and to jump off a DOJ example, imagine the witness protection database against the air traffic control system. So in witness protection, you can imagine that confidentiality is probably pretty important, right? It depends on the people. The data integrity, probably mildly important to pretty important. But availability, my guess is that database can go down for an hour and nothing bad is going to happen. Kind of the inverse with the air traffic control system, where a system availability is paramount. Also, integrity is pretty darn important, right? We need to know where the planes are. But confidentiality may be less so, in that we want people to know where the planes are. That's not actually data we're trying to keep secret. So, understanding the goals of what you're trying to do with the data as you define these systems, and certainly I think it's a challenge for a lot of people to sort of switch their mindset to start thinking in that sort of a way. People tend to be sort of gung-ho, rah-rah about getting a system in place and see these sorts of questions as just hurdles to overcome with the lousy IA people who are making you go through these analyses. But really, if you actually use these techniques properly and well, you can actually design an environment that performs the way you want it to and ultimately achieves the goals you're hoping to hit.
It's good those guys went forward, gave me a chance to think. No. Seriously,
we'll go the other way next
time.
No.
You're first guy for the next.
The thing that I think about when I meet with a lot of our clients is people have data in all of these different places, in all of these different schema, in all of these different storage formats, and there's no way to bring it all together and find insights from the data. And in 2015, Google wrote this white paper. It's called The Hidden Technical Debt in Machine Learning Systems. You can find it on the internet. It's like the seminal paper. And what Google analyzed was, they're really a leader in machine learning. And what they did was they studied their ML data scientist guys. They said, how are you guys spending your time? Turns out, a lot of the time, the majority of the time, was spent doing data transformation, feature extraction, infrastructure setup, monitoring of the jobs. And when it came down to it, I think they represent this in the paper as a set of boxes, and the boxes are representative of the amount, the size of the boxes are representative of the amount of time that they spend doing all of these things. And the part that's machine learning is this tiny, tiny, tiny little box in the center of the diagram that shows that actually writing the machine learning code and building the machine learning model was a really tiny part of their of their work. And so my recommendation to people is find out what data you have, inventory your data, and find a way to get it to a single place or to at least accessible from a single environment. Once you get your data and you get your schemas set up and you get your quality of your data right, then the world is your oyster. But I would say to you, most of our federal customers, most of the people that I talk to in the federal government, they're at stage one. Just finding the data and getting it in the right format, in the right schema, in the right place, so that they can do something with it at the future. And data engineering turns out to be a really important part of any type of advanced data analytics.
You alluded earlier to a battle royal that's just perennial between the data engineers and the data scientists.
Yeah.
Right? So the data engineers want to be the ones in charge of the ETL. They want to be in charge of creating the data warehouses and the infomarts. And the last thing they want is for the data scientists to have access to any of the raw data because, it's raw data. Why would you want to look at my beautiful infomart over there? Surely you want this. And the data scientist says, it's lousy. Like, I can't do any of the stuff I want to do.
Not only is it lousy, is it's late.
Yeah.
Particularly if you're dealing with, cyber analytics where if it takes a day before it gets into my gold storage, well, that's too late. I might have missed a thread at that point.
That challenge, though, of creating, there is some value to ETL, I'm sure you'd agree, and certainly when you're talking about consolidation of data from multiple classification levels and other things, right? So there's work that has to be done there to get the data in some usable form. So the question is, when do you allow the data scientists into the early data? Because they could draw wrong conclusions, right? We don't want them. We want to protect them from themselves sometimes, or just
Well, and very frequently the quality of the data is poor. So if you're analyzing poor quality data, like you'll get absolute results that are absolutely wrong.
Exactly.
And so it's really important. So there's a constant trade-off here between when you give that data to the data scientists and when the data engineers start with it.
What are your thoughts on that?
Yeah, I would just want to amplify that because there's a really important reason why what you're saying needs to be understood well. And the primary reason in the federal government is because we're moving to a smart cloud strategy as opposed to a cloud-first strategy. So what that suggests is that the impetus to combine and converge a data science and analytics capability with cloud is part of why we have this new mission capability around smart cloud. It also requires us to think much more clearly about the kinds of quality, classification, tagging, labeling, and wrangling of data as it goes into the cloud long before it starts to be part of an analytics solution set. And so if we put bad data in a hybrid cloud model that includes multiple clouds and the enterprise and maybe private cloud, then this is what happens. So the suggestion, the recommendation is don't put bad data in your cloud. Identify a way to understand the provenance and all of the metadata that's associated with data before it goes into the cloud so that no matter how it's used, it would be ready for ingest and
Well,
I think we have a question, actually.
Oh,
Yes.
Wow, go ahead.
How do you square that with what you said earlier? Should we be doing this? You need to be able to find some way of understanding whether the result is worth it before you go ahead even and do all the...
So the
If
question
we could get
is...
the mics live, please.
Yeah, so the question is, how do you square that with this comment I made earlier about should you do this? And so that comment is really focused on the legal, societal, and ethical implementation and implications associated with artificial intelligence and data science. There are many things we can do with analytics that we see other nation states and other folks do. One example might be the use of machine learning for adversarial environments, especially with GANs. So when we take a look at a GAN, you can see that there's some really great things that have come from them, right? So we've seen whole new art forms exist. Paintings have been generated by machine learning. But GANs are also the very mechanism that we use to create deep fakes. And so the question isn't whether or not we can do something. The question is, should we do something? Now, this is not really applicable to the conversation we're having about should we move to the cloud versus not. Certainly there's a business justification that needs to be put together for that move. But most federal agencies are adopting hybrid cloud strategies. And because of that, data goes into the cloud of a certain quality. And if it's not quality ready for analysis, then it requires advanced tools like Databricks and Microsoft and many of the other folks inside the Intel ecosystem in order to get it ready for analysis. So the suggestion is, before it goes in, clean it up.
And think about it this way, right? So there's a hierarchy, right? You want to at first start with some very big top-level questions. You know, what are the implications of gathering this data? What happens if someone gets their hands on it? What happens if I make a mistake with it? And what conclusions are going to be drawn from it? You know, regardless of what tools I then use and what mechanics I use to manage it and make it available. They're just some starter questions you need to ask about societal impact and ethical implications, et cetera, and some of the confidentiality, integrity, availability notions that I was discussing. But then from there, once you've figured out that question, right, what happens if everything goes well, what happens? And then from there, you can start getting into this morass of what tools to use. And I mean, there are, that's also one of the big challenges, to go back to your original question, Karina, the enormous number of tools on the market to help you, in many cases, do some of the same things. And some of these get into like religious battles. Do we use Jupyter? Do we use Zeppelin? Like, you don't want to ever get in the middle of that argument between two data scientists. So, you know, there's tiers, right? You get down into that, and then you get into like questions about data models. You know, there are a number of different conflicting, data warehouse concepts that again get to very religious kind of fervor. So figuring out the right model to achieve the right goals is ultimately a lower level decision, in my opinion.
Hello, I'm Tom. How are you? Hey, Howard.
Hey, Tom.
He used to be my boss, actually. Well, he's still my boss, right? I defer to your wisdom. I guess, Sarah, you were talking about the should question, and I think should, yes, but maybe a preposition such as why should we do something, followed by the how. Yeah. Is that the right way to look at it?
Well, I think there are a lot of facets to data science. I think why we should do something is important as should we do something, right? Should we take the health data off of a person that wears an Apple Watch if they're in the emergency room and they haven't signed a release for the data that's in there? Because it might save their life, but it might violate their privacy. So the question isn't whether or not we have a mechanism for doing it. We probably do. The question is, should we do it? Now, the reason this is important is because data scientists are starting to buy liability insurance. Why do you think that's happening?
Well, you get into that good of the one versus good of the many thing from Star Trek days, right?
Yeah, so if data scientists are buying liability insurance, what does that mean? That means somebody is starting to hold data scientists accountable for the insight that their algorithms create. Mm-hmm. If your algorithm is 85% wrong, and of course Gartner is saying that data science projects generate about a error rate of about 85%, 17 out of 20 will not meet the expectations associated with the person who's running the project. You can see why insurance in data science is going to skyrocket, much like cyber insurance. When there's a breach, you don't think the company pays, the insurance company pays. And that's what you can expect to see if we do not get better understanding of whether or not we should do something.
We're not aligned on those subjects either as a society at all.
Not at all.
In my opinion, right? So that question, there's long been legal precedent that allows individual rights to be suppressed for the good of the herd, right? So whether it's not being allowed to shout fire in a crowded movie theater, or not having the right to take your own life, or things that society decides are not in its best interest, your rights are very typically suppressed. And there's arguments on either sides of some of those.
Yeah, but Jason, that's really not the example that I would use. Although I certainly agree with that. Let's take this example. I'm in elementary school. I want to create a personalized learning program for each student. I want to be able to evaluate and test them so that I can ensure that people who learn through images get that, people who learn through text get that, different learning styles, right? So what do I end up with? What I end up with is a ranking of students. Now, what if I keep that ranking forever? And that ranking determines what high school they get into, or what college they get into, what job they can get, or what person they can marry. So we are not far away from these kinds of eventualities. So the things that we think and take, this is what we're doing to try and solve a real problem. It's good, right? We want kids to learn better. We need to think more clearly about the implications. So that's the kind of example that I'm talking about.
So Melvin, just to bring it back to earth a little bit.
Thank you.
I love you.
I like
No. But seriously, I mean, when we're talking about federal agencies, and a lot of them are, let's take a Microsoft product, are doing Power BI to see like how many trips people are taking or whatnot. Like, at what level are we really now in adopting data analytics, and are we really prepared? We're talking about data scientists and whatnot. There's a lot of talk of maybe we don't need a whole plethora of data scientists just to get through like the initial stages of having that, democratizing data to have analytics to provide better citizen service, whatnot. So just kind of take it down to the here and now.
I'll let Howard go first.
That is a profound point, and I work for a company that's headquartered in Silicon Valley. That is the founders. There are 6 of them. They're all PhDs from Berkeley, all creators of Spark, and they live in this little bubble that I say is off the charts because they deal with Uber and Google and Facebook, and those guys are doing really advanced machine learning. But I believe that as you move outside of that little Silicon Valley, and it's like a logarithm in terms of where people are in that advanced analytics curve. And I would suggest to you that almost none of our federal clients are doing what I would consider to be machine learning. They're all doing data science, analytics, but it's not machine learning. And Power BI is their best tool, yes. And they're getting very effective results just by pulling together the data. Now, I do think that there's an opportunity there for our federal clients, but I think you've got to walk before you run, and I think we've got a long way to go before. And I've shifted our company strategy, which has really been, around these machine learning lifecycle management capabilities that I alluded to, ML Flow, to what we're delivering to our federal clients today largely is data engineering, data warehousing, and simple analytics that they can do with business intelligence tools. And part of that goes to the point that Mel made earlier, which is just the amount of training in order to leverage machine learning. It's going to require a significant retraining of the workforce in order to get there.
What does that organization look like to be able to manage, how are we going to retrain? What does that look like?
Yeah, that's a really good question. I'll give you one personal story. My daughter graduated from University of Maryland a year ago with a degree in computer science, and I said to her, hey, what do you know about SaaS? And she's like, software as a service? I'm like, no, SaaS, the analytic? She's like, I never heard of it. And then, she took a job, and the only thing she wanted to do was program in Python. And I think that, a lot of her friends and colleagues were kind of at that same level. And there's no surprise that Python's like the most popular programming language today, and frankly, the language of data engineers and data scientists. So I think that's starting to happen, but it's going to take a while because we've got to matriculate people through the system.
And not to put the brakes on Power BI or any awesome front-end analytics, but
No, it's a
before
start, yeah.
no, I think data democratization is a fantastic goal, but we also have to be cognizant of what data we're democratizing, and there has to be some sort of a data access bus, in front of those analytics
Absolutely.
tools, so we can just make sure that the right data, the wrong data isn't getting into the wrong hands, or the right data in the wrong hands, that the data isn't going where we don't want it to, and that people don't use it in some of the nefarious ways, that Mel was alluding to.
So I'm going to disagree with my colleagues a bit, because I think there's an important trend that
Cut the mic.
we want to capture, because the window is closing on data scientists being the arbiter of data science soon. Soon, tools like Power BI and all these other tools, they're not built just for data scientists. They're built so that people who have access to data who are not data scientists can use them. That's the whole concept that we saw on the stage. So what you can expect is that in a very short period of time, it would become clear that you cannot operate in this civilization or society without data literacy.
Yes.
And we will be changing the complete focus of this discussion from how do we train more data scientists to how do we train more people to be more data literate. And what that will spawn is a set of citizen data scientist capabilities. Remember, the data does not come from the data scientists. It comes from the masses. And the sophistication level associated with the average citizen is growing. They are absolutely starting to become aware of the fact that billion-dollar businesses are built on the backs of the data that they give away for free. And they want a piece of that data, or they want to find a way to manipulate the data on their own to get access to that revenue. So
I just finished reading this book called AI Wars. Anyone familiar with this thing? It's by this guy, Kai-Fu Lee. It was a New York Times bestseller, and it's about he's a Chinese venture capitalist. And he is totally convinced that China is going to wipe America off the planet because they're going to be better at machine learning. And the big basis for his commentary here, you tell me if you got the same thing, but is that they have more people and they generate more data, and more data leads to better machine learning models. And our CEO always says, like, AI has been through two what they call winters, where we did symbolics and list programming and it just didn't work, and then we did some other stuff and it didn't work, knowledge capture. And he says the only difference with machine learning today versus what we did 20 years ago is more data. We took the same algorithms that sucked 20 years ago and gave them more data, and all of a sudden we're getting accurate results. And Kai-Fu Lee's position is they have more data and they're going to win the race because they can synthesize more data because they have more people.
I mean, unless you put synthetic data in those data models.
Well, I mean, a lot of the data, he talks about like Baidu and Tencent and Alibaba and all these companies that are growing more quickly than Facebook and eBay and everything else, because the size of the overall Chinese economy is so significant.
I guess one last question. Yep.
Oh, thank you so much for the fantastic conversation. I would love to hear the panel opine on the intersection of a couple of ideas here. One is that we're all well aware that de-identified data, according to HIPAA terms, can now be re-identified, yet we live in a policy and regulatory framework that believes in a now defunct paradigm. The establishment of the chief data officer in U.S. federal government agencies on the supposition that data is an asset. Assets require valuation. And what about the treatment of data as property under the law? And if the U.S. government is one of the first parties to formalize that under the public sector in this market, how do you think that influences the evolution of the space?
So I'll take a crack at that.
Thank goodness.
Yeah. That was hard.
So certainly treating data as an enterprise asset is the role of the chief data officer. And whether or not they are doing so in combination with the CIO or the CTO at an agency, this is becoming the most valuable asset that the agency has. And so that's why all this attention is being brought to it. What we're seeing, however, is that at an individual level, it means that the people, as I mentioned, are going to start wanting to get more participative into this revenue generating capability. And so we're expecting to see the development of data exchanges. Mm-hmm. This is where people are able to sell or rent or offer their data for a certain price. If you want my name, it costs you $50 a month. If you want where all my friends go to dinner, $100 a month. If you want to know where I shop, it costs $200 a month. So this advent of data exchanges is coming. People want to get paid, realizing that data is generating billions of dollars for other people. I think the other thing that's pretty interesting about your comment is the legal framework associated with data is changing, right? So today, we rely on third-party intermediaries for the administration of the data security and privacy frameworks that we use, right? I think this is not going to be the driver for AI adoption. We are likely looking for a zero-trust model, some sort of hyperledger implementation that will allow a peer-to-peer communication that is secure only between these two individuals that want to share data between them, and less focused on a central authority that will drive the adjudication of the transaction. With that comes a full set of responsibilities around the use of data. So we would likely be seeing this first focused on where data is being weaponized against the people who actually give data to have the data weapon created, right? So if I want to stop people from voting, I find out where all the people vote, and then I make it illegal for them to vote those days, that time, those places. So the development of data weapons is something that is happening constantly. And I think this democratization we talk about comes with this adjustment to the legal framework, as well as an adjustment to the revenue business model.
You know, that the example of data weapons, like that's in a way the Moneyball concept I mentioned earlier. Like that, this has been going on long before we had these sophisticated tools at our disposal. Gerrymandering was happening in Chicago, 50 years ago. And that's a data weapon. That's actually using the data at our disposal to try to influence an outcome that might be ultimately undesirable, even for society at large. And I'm glad you mentioned the blockchain concept, because that's where I was going to go with this. Because ultimately, you're going to get into a situation where it's actually the metadata about the data architectures that becomes important. And that in itself, there's a machine learning opportunity there to figure out how data is going to be used in combination and reverse engineered and derived and reaggregated, et cetera. And that's not something that we can pre-plan to a certain degree, but we do have to ultimately put machine learning models in place to figure out how data can be misused or how it can be used to achieve goals that are counter to the confidentiality, integrity, and availability targets that we're actually setting for ourselves. And I personally think that blockchain smart contracts are a fantastic way to ultimately do that, as we then use machine learning algorithms to build those smart contracts. But now we're just talking crazy. So.
Well, no, I don't think so. I think we're seeing it already implemented in health and life science data.
Yeah, to a degree. Yeah.
Well, I would just add one tiny little piece to that, and that is like the rules of Hipaa actually, and Dongwa, you probably know more about this, but it's holding back our ability to do big data analysis in healthcare and find better health solutions. So it's I don't know what the answer is. You guys probably know better than I do, but it's definitely a challenge and a problem. And we all know from Cambridge Analytics, how, our data can...
Well, so Howard, is it unreasonable to tell people what we're going to do with their data? To be more transparent?
Yeah.
Is it unreasonable to share, hey, you know what? I'm collecting all this data about you so I can sell it to somebody else so that you can get a recommendation about a car?
Well,
but I think what's causing consternation is that we kind of try and do it on the QT, undercover, right?
Sure.
Yeah, so I think there's no reason why we can't be above board.
But we all kind of know, like when...
No. I think that's
I'll tell you a very funny story.
If you're not paying for the service, you are the service.
So I think that's where we have the problem. We think we kind of know.
I
You and I kind of know.
I have
think,
like an Amazon Echo and a Google thing at home, and my wife's like, man, they're listening to everything that we're doing. And she's
They are.
like interested in refurnishing our family room. And like this massive 500-page catalog comes from Restoration Hardware, like out of the blue. She's like, I told you. And I was like, isn't it good? She wanted that catalog.
See, so
No.
this is like an example of should we, and if we do, let's find a way to be transparent about it. You know, I'll tell you this: my wife knows I'm here today, right? If I decided to go somewhere else and she found out about it, that would not be transparent. She might take umbrage with that, right?
Depends on where. Can we
No, it doesn't really matter where, right?
No, trust me about it.
But if I decide, you know what, I think there's no reason why I can't be transparent and less opaque about how I'm actually using people's data and what I'm going to use it for.
But it sort of implies, though, that we know, what's actually going to happen. Like, I can say I'm giving my data to X, but what is X really going to do with it? And how are they going to aggregate that data with other data they got from some other vendor? And then what does that imply for me? I love the story of the 16-year-old girl who bought prenatal vitamins and what to expect while you're expecting at Target, and then got a letter from Target a week later saying, hey, congratulations on being pregnant, only, her parents didn't know. And, imagine their surprise when they opened the letter from Target informing them that their 16-year-old daughter was pregnant. Because that's the world we live in now. So
Yeah.
these are unexpected consequences.
So what did I tell you? This is a lively bunch, and that I didn't need to even sit here because you were self-moderating.
I think you asked one question.
Yes,
Sorry.
but no, this was a great conversation. I think it gave a lot of food for thought. One also, like, I am not sharing any of my data. I'm going to make them pay for it, but no. No, seriously, I think there's a big path for us to learn how to organize data, how to organize our organizations for data, and our mindset of how we use data. So with that, I want to thank you all for the contributions, and we have a little bit of time for networking, so please join us.
That was a lot of fun.
Good job, Mel. Always fun. Always fun.